Hey everybody, it's Tucker with Augmented Ink, and today I wanted to go over a solution which we found for a specific scroll behavior that we typically run into in our app, which is smooth scrolling, locking into a set position, and the ability to be able to wrap or have infinite scroll. Now, you may be familiar with this scroll rect component as it is in Unity. We have it right here on our content object, scroll rect. You can add a scroll rect component to an object in Unity by going to Add Component, typing in scroll, and it appears right there. This component has a content and viewport area for rect transforms, as well as some scrolling options. Horizontal and vertical. Of course, you can scroll in many different directions. Most of the time, you only want one of them, as well as some additional options here. It's very important that you do set the viewport and the content correctly. Our content in this case is the object that the scroll rect is actually on, and our viewport is the parent of that object. Essentially, what that means is that the content is going to scroll in the bounds of this box. Now, you may notice when I'm scrolling, I can go up, but it zoops right back down. Down, goes all the way right back up. And that is because our scroll area is roughly 2,500 units tall, but our content is only 100 tall. If we make the height of the content twice as much as its viewport, then we will be able to scroll all the way to the end. Now you'll notice I click and I drag upwards and I let go, and the inertia continues to allow that to move up. Additionally, it doesn't really respect anything as far as snapping to a grid. I can't stop it on any given point. It's always going to be a different thing, kind of like the big wheel on the Wheel of Fortune. But conversely to the big wheel, it doesn't go all the way around, and it stops at the end. These are things that we needed to have in our app, so we created a solution for it. And that solution is right here. On the scroll canvas, we have the background, top bar, an icon title background, and the scroll background. Now, the icon title background is lower in the hierarchy than the scroll background, so that when you do scroll this, it goes behind it. As you can see over here on our scroll background, we are using a scroll rect, but we're only using it to go up and down in a very limited capacity, just so that we can show this content that would otherwise be off the screen. The actual solution that we've come up with is the horizontal scrolling of these subsets. As you can see, there's many subsets off to the side of the screen. And if we move left, we can move one at a time. Doesn't matter if I click on this one and move all the way over, I'm still clicked. It won't do anything. It only moves in one in either direction. And you see it actually wrapped all the way around. It started out with everything being either on the screen or to the right of the screen, but once you start scrolling, some of the items are going to be on the left, some of them are going to be on the right, and as you scroll through, the one that's furthest to the left is going to jump to the right, so you get infinite scrolling. Additionally, if you go backwards, you stop at the appropriate one. So, on the green one, you have some scrolling activity. There's the first one. Go backwards, and you can see there's the first one again. It doesn't matter. You can scroll as much as you want to the left. Everything operates fine. Now down to the bottom one, same deal. There's just more here, and it gets almost all the way to white, and you can go back. So one thing you may notice is that it doesn't care if you're already scrolling in one direction. You can scroll in all directions because of the scroll rect that we have on the scroll background. We may want to change that in the future so that input is more easily accessible by the user. But for now, I think we're just going to leave it how it is. Now, how do you do this, you ask? Well, first of all, you're going to want to have some content, and you're going to want to organize it similarly to this. I won't go over the creation of this content here, but essentially you're going to have subsets which hold these parts aren't necessary for it. It's just the title up here and the little divider. What you want to scroll is actually these totes. And these totes are created by a background, bottom background in the top case, which is, let's get this one right here. Where are we? Bottom background is just that. And then we have the temp mask, or the tote mask, excuse me. If you wanted to have masking for your actual object here, you would go ahead and add that sprite in so that you can maybe have rounded corners. As you can see, these are sharp corners. Then we have the hero image, the title, and the address. So basically we're scrolling this object. The rest of the objects that are on there are just children of that object. And we're scrolling them independently of each other. I can scroll this one that way. I can scroll this one either way. It doesn't matter. None of this scrolling direction really matters as long as you're scrolling on one and you know which one you're scrolling on. So once you have your content created, this is how we're going to do it. First of all, we have this wrap tote container, and it's going to have these functions here for how many you want to shift. In our case, we're only shifting by one, so we are only wrapping one piece. And what that does is wrap forwards. It's going to basically change the indices in that array so that you can continue to swipe forwards. Then our update function, this is where we go ahead and do the scrolling. So what you're going to want to do is record your click position as every frame. And then you're going to want to change delta by subtracting previous click position from click position. And then we're handling everything in a switch case, which is called app state slideshow. You can call it whatever you want. But it basically boils down to we have a select state, meaning you have not really done anything and we are checking to see if the mouse is present. And then we get the mouse button down, which is the left click on the 0 here. Once we do that, we record all the data for the click position. We create a new raycast, and we check the raycast results versus our subsets. So we get the object, and we say if that result 0 game object is equal to a tote inside of subset 0, then we're going to set the current subset to 0. Found subset is true. And we're going to change our slideshow state to slide. Additionally, we're going to set this global slides here. And what you're going to want to do with that is if you need to use that information, know what was last clicked, know what is in focus. If you only have one thing in focus, it may be useful for your case there. Additionally, if we haven't found the subset, we check the next set of subsets. And if we still haven't, we check the last one. And if you still haven't found it, oh well, just try it again. But once we do go to app state slideshow slide, that means we are currently sliding. In which case, we want to do a switch case again. If we are currently sliding, then we have advance equals false. We're using this to know if we should advance or not. Then we're taking a vector and calling it addition vector, which is just going to be the delta.x and 0, 0. This is how you're moving it horizontally. If you wanted to have this vertically, you would have a 0 here, and this would be delta.y. So what we're going to do is basically loop through the subset container and adjust the position for each of those totes by that addition vector. Now you'll see it's plus equals addition vector, and that's okay because if you're moving to the left, then that's automatically going to be a negative number in the delta.x. So you're going to be adding a negative number and it's going to move everything to the left. Now we're still in sliding. So what we're going to do is when the mouse button goes up, we're going to advance and change it to slideshow end. When we do get to advance, we're going to record some additional information. And this is crucial in order to make sure that you can move your slides to the correct position on the screen. So up here we have a difference vector. We have previously recorded a base slide position for any given subset, and we're going to subtract the actual global slide position from that. Our difference magnitude is going to be that difference vector dot magnitude, and we're going to be using that to check if we have a scroll target value. Scroll target value is a percentage of the screen width. In this case, it's 1% of the screen width. If you have a 1000 pixel wide screen and the user scrolls a little bit, 9 pixels, that doesn't do anything, then advance is not going to do anything. They have to make a meaningful swipe in order to actually do it. Otherwise, any click, swipe, or anything is going to iterate this slide. Additionally, up here, we do change the target slide position of the current subset to the base slide position of the current subset. The reason for that is the base slide position is always going to be that left side in focus position, and the target slide position of the actual slide that we are moving to is going to be set to that. So we have the difference magnitude. We're checking it if it's less than the scroll target value, or greater than, than the scroll target value. And if it is, we want to make sure if we're going in one direction or the other, so we can iterate our indices. You're only going to really need to iterate our indices if you have a need to for another function. We did have a need to in our actual app, so we left that in. So we're going to break down here, and then the case would be end. So at this point, the user has swiped. They have swiped far enough in order to actually move the index, and we're going to display that. So what we're going to do, we're going to have, again, a difference vector. Now it's going to be target slide of the current subset. Subtracted the scroll subset dot content with the current index of the current subset dot tot dot transform dot local position. Now that might look a little bit confusing, but if you have any questions, you can leave them in the comments. I'll be happy to answer them. Additionally, we want to have another magnitude there. And as long as we have a magnitude, then we're going to try to change the position here. So we have an int, which is a diff. This means if you're basically to the left or right of the current subset, or the current slide index. We're going to loop through that subset for all the contents. And for each one, we're going to make diff equal to I minus the current index of the current subset. In order to move all the additional pieces, we want to make sure that we multiply their position by diff. So obviously the first one's going to be 0, and so on and so forth. So the diff is essentially how far away your index is from any given index. And then at the end of this, we want to change app state slideshow to 0, app state slideshow slide to 0, and we want to reset current X to 0. So we've gone through that case and we've gone through this this case and we've broken. And at the very end, we're going to change previous click position to click position. That way we can always have a piece of our, we can always have the correct position of our mouse for the new frame.